EGR. We're going to just kind of run through this real fast. Hit the high points. EGR stuff. Come on. Reddish brown haze. That's the oxides of nitrogen. But you look at Chicago. It's in the morning. It's not bad. As the day goes on, it gets worse and worse. Uh, this is caused by NOx, and NOx is just the nitrogen inside the atmosphere that's drawn into the engine. Once it gets to a certain temperature, about 2,500 degrees, NOx starts to form. Now, NOx is formed earlier than that, but in a much smaller amount. It's in full swing production when it gets above 2,500 degrees inside the cylinder. Normal cylinder temperature is about 1,700 degrees. So, it's a pretty hot cylinder. Usually this is uh, part of being a lean cylinder. The lean cylinders burn hotter and faster. We want the cylinder to be lean because we want to save fuel, but that comes at a price. We lean out the mixture too much, and the in-cylinder temperatures get very hot and it starts to produce NOx. And NOx is bad, and especially when it combines with the HC that's coming out of the tailpipe as well. That's what produces the photochemical smog. Now, the purpose of the EGR is to help slow this process down of NOx formation. There's always some NOx forming, but a richer cylinder burns slower and cooler. That doesn't really have the problem. And most books, as a matter of fact, every book, our book, describes this as it dilutes the air-fuel mixture, but that's not exactly true. The gas is inert, which means it doesn't do anything, but its job inside the cylinder is to take up space, if that makes sense. Think of, putting ice in your beverage. As the ice melts, it dilutes the mixture and it makes it taste different. But we don't want to make the flavor change. So basically what this inert EGR gas does is it takes up space, and that helps slow the burn down. And if we slow it down, it doesn't burn as hot. Much the same way as blowing on blowing on a fire to get it started. It put more oxygen in it. It burns hotter, but it also burns faster. Does that make sense? So EGR is designed to operate generally at a steady cruise. Now, it's not supposed to operate at a cold engine just because it doesn't need it. The cylinder is not hot, and there's already an excess of hydrocarbons in there. It doesn't work at idle because it's extremely detrimental to idle. And then the computer also shuts it off during wide open throttle or heavy acceleration because you want to go fast. So, and then plus if we're going wide open, it's going to be a very rich mixture anyways, and EGR isn't needed. Pretty much any other time that it can flow, it will. Especially, like a steady cruise down the highway, that EGR is going to be holding open a little bit. But it won't do it at idle conditions because it's so detrimental to idle. Now, there's a couple different kinds: vacuum, electronic, and then all electrical. These things started out a long time ago, using ported vacuum, and then there was this switch. It was in the cooling system, so the switch wouldn't allow vacuum until the car heated up. Yeah, it's old. These are some positive back pressure EGRs. You can look them up online. I'm really not too interested in going over them. Just suffice to say, here is the important point that you need to know, is when the exhaust valve opens, there's a slight positive pressure. This slug of exhaust gases coming out of the cylinder creates a positive pressure inside the exhaust system. We good? We also have a negative feedback one. And both the negative and the positive feedback EGR valve, this is to regulate and modulate to a much finer level the amount of EGR flow. vacuum's commanded open by the computer or just by vacuum, there's this hollow stem opens and closes this bleed valve based on whether it's positive or negative pressure. Now, the other part that you need to understand is this slug of exhaust that leaves the cylinder. Once the exhaust valve closes, this slug of exhaust has some weight. It has velocity. It has some, I don't know, inertia. So as it comes out of the cylinder, it's traveling at a high rate of speed, due to pressure pushing it out, and it's got some mass to it, think all air does. Well, when this valve closes, this continues to move, and that actually creates a negative pressure behind the valve. We good with this statement? I'll bring this up again later. And then we have these electronic ones. They have to have some way to monitor how much flow there is. This one uses a direct potentiometer on top of the EGR valve to monitor how much flow there is. It's a feedback for the PCM. There's a couple of ways that they do this. One is by monitoring the pin tool directly. I'll pick on Toyota. Toyota, this is a hot exhaust gas that comes up through here when this is open. Toyota puts a temperature sensor right next to the EGR passage in the intake. So when this valve opens, it sees the heat from it. It's one of the ways they do it, or they monitor MAP, more on this in a second. These are all electronic vacuum operated with a solenoid, and this is very, very common. Depending on the system, how these operate and are slightly different, but a solenoid is just a coil of wire, and I got B plus on one side and a ground side switched to the ECM. I ground this line and this guy opens or closes, and this guy gets vacuum, and the EGR flows. And it could also be a negative or positive modulation, EGR on this guy. So the computer controls the rough opening, and then the fine amount of opening is controlled by the EGR, mechanical EGR valve itself. Some of these guys are 3-wire potentiometer. It just goes straight back. I think I showed you a picture of that just a second ago. This is DPFE. This is a Ford one, but Ford isn't the only one who's doing this. And the way this works is, here's my exhaust stream coming out of the cylinder, and then this is my EGR passage. Here's my EGR valve. Here's an EGR solenoid. So when the solenoid flows, tells this, vacuum energizes this vacuum servo right here. It opens and flows into the intake. Now, here's my monitor for this. It's using what's called a DPFE. This DPFE sensor goes to this EGR tube coming out my exhaust, and there's a restriction in between the two lines. Well, when it senses flow, the pressure changes between these two lines. This is a differential pressure sensor. Okay? So it senses a difference in pressure between these two. It can gauge how much of a difference pressure there is, how much flow there is. We're going to look at this system out in the shop. We also have these all digital ones, no vacuum at all. This is probably the most common. This is an early GM. It's got 3 different solenoids on it. They are different flow rates for the 3 solenoids, small, medium, and large. Some only have 2. The computer's in charge of these guys, and it can open 1 or 2 or 3 or any combination of these 3 at any time he wants. It does improve the accuracy quite a bit. Faster reaction times as well. We don't have to wait for vacuum to do its job. Then we have these linear EGR valves. This is kind of what almost everybody uses nowadays, controlled exactly by the PCM. PCM knows exactly where this guy is, and it does monitor MAP, and TPS on this system in order to gauge how much it's opened. And it does that by looking at, when, it'll open up the EGR at idle. It'll see the idle drop. See the EGR open, idle will drop, and then the manifold pressure, will indicate a change as well. So this is how the EGR tests, or the computer tests the EGR. Now, it's looking for pintle failures, and it's checked once for flow per ignition cycle. High or low flow rate will set a DTC. The EGR is normally commanded open. The computer is normally using the EGR during cruise or deceleration. Now, this can be an intrusive test where the customer will notice, but usually it'll idle. It'll do it at idle. It'll open the valve and it'll look for a rough idle. And if it doesn't see it, it may flag a code. And the customer may notice this, but this may take a while. Here's the important part that we need to know. PCM testing only happens once, except for FIR and RSR. Fast initial response is enabled after a code clear, and a rapid step response is enabled after an abrupt change in flow rate. We are going to be looking at this when we get into the lab. I'm going to be demoing this part. And it's really handy to know this if I want to try to look at the EGR or test the EGR. I've told you before many times, we shouldn't be clearing codes, but this is one of the times where if I want to easily test the EGR, if I want the EGR to react, I can just clear the codes, and then it's going to go into this FIR really, really quickly. And almost everybody does this if it has an EGR. All right, that's about it. Oh, one thing I wanted to say was EGR really isn't used by a lot of manufacturers anymore. What's taken the place is valve timing. We now use valve timing instead of EGR. So you see a lot of cars come through and they don't have an EGR anymore. We good? Okay, thanks.